Okay, so here we're going to talk about perpendicular bisectors in triangles. So here we have a triangle with vertices A, B, and C as shown on the graph. So we could draw in that triangle. But in fact, when we talk about a perpendicular bisector, we don't actually need to be talking about a triangle. It's a little bit different than when we're talking about a median of a triangle or an altitude of a triangle, where we definitely need three vertices to work with. When we talk about a perpendicular bisector is just based off of a line segment. So if we're going to determine the equation of the perpendicular bisector of AB, all we need from this triangle is line segment AB. Vertex C is actually not going to be useful to us at all for this particular question. So here, the focus is on the term perpendicular bisector. Perpendicular, we know, means 90 degrees, and bisector, we know, means to cut something in half. So the perpendicular bisector of AB intersects AB at a 90-degree angle, so perpendicular to AB, and because it's a bisector, it's going to cut the line segment AB in half. So the perpendicular bisector of AB goes through the midpoint of AB, which we don't know the coordinates of that midpoint yet, but the perpendicular bisector will go through that midpoint and it will connect at a 90-degree angle. So those are two things that we want to make sure of. So because we know it's going to go, this new line, the perpendicular bisector, is going to go through the midpoint, let's start by finding that midpoint. So we're going to find the midpoint of line segment AB. So we take the average of the x coordinates. So here we have -5 plus -1 divided by 2. And the average of the y coordinates, which is -2 plus 6 divided by 2. And that gives us a midpoint of -3, 2. Okay, so we know that the midpoint is at -3, 2. And we've got it pretty close to there right now, so right here. So -3, 2. Now, we also know that this perpendicular bisector is at a 90-degree angle. And so we know that the slope of the perpendicular bisector will be the negative reciprocal of the slope of AB, because negative reciprocal slopes is what tells us if two lines are perpendicular to each other. So to find the slope of the perpendicular bisector, I'm first going to need to find the slope of line segment AB. So here we're going to find the slope of AB. So the slope of AB, we're going to start by subtracting the y coordinates. So 6 minus -2 over, then we subtract the x coordinates, -1 minus -5. And so here we get 8 over 4, which is equivalent to 2. So if the slope of AB is equal to 2, then we know that the slope of the perpendicular bisector is going to be equal to the negative reciprocal of 2, which is -1/2. Okay, so we have the slope of the perpendicular bisector is -1/2. And we also know that the perpendicular bisector goes through the point -3, 2. So if we go back to that picture for a moment, the slope is -1/2, and the perpendicular bisector has to go through the midpoint. That's the only point on this graph that we for sure know that the perpendicular bisector goes through. It may coincidentally also go through vertex C, but vertex C isn't really relevant in determining this perpendicular bisector. If it does go through point C, then that's just by coincidence, and that does not happen with every triangle. So we have a slope of -1/2, and the line will go through -3, 2. So we know that the equation for this perpendicular bisector is in the form y equals -1/2 x plus b. And in order to determine b, we can substitute in an x and y coordinate that come from a point on this line. So I can substitute in -3, 2. So 2 is replacing y, and -3 is replacing x. So here I get 2 is equal to 3 over 2 plus b. And so 2 minus 3 over 2 is equal to b. And so b is equal to 1/2. And so that tells us that the equation of this perpendicular bisector of AB is y is equal to -1/2 x plus 1/2. Okay, let's do another one of these. Here we're going to determine, we've got the same triangle ABC with the same coordinates. Here we're going to determine the equation of the perpendicular bisector of line segment BC. So in this case, if we're finding the perpendicular bisector of BC, then vertex A is not needed in this question. We just need to focus on line segment BC. So again, we know the perpendicular bisector will go through the midpoint at a 90-degree angle. So let's start by finding the midpoint. So the midpoint of BC, we take the average of the x coordinates, so -1 plus 3 divided by 2, and the average of the y coordinates, 6 plus -1 divided by 2. And that gives us the coordinates 1, 5 over 2, or 2.5. We also need the slope of BC because that's going to allow us to determine the slope of the line that's perpendicular to BC. So the slope of BC, we subtract the y coordinates, divided by, we subtract the x coordinates, and that gives us -7 over 4. So we have the slope of BC, and that tells us that the slope of the perpendicular bisector is the negative reciprocal of -7 over 4. So the slope of the perpendicular bisector is 4 over 7. So when we put together this equation, we know that the slope is 4 over 7. And we know that the perpendicular bisector goes through the midpoint, which was 1, 5 over 2. So the equation is in the form y equals 4 over 7x plus b. And to solve for b, we can substitute in this 1, 5 over 2 for x and y. So we get 5 over 2 is equal to 4 over 7 times 1 plus b. So then 5 over 2 subtract 4 over 7. So we subtract 4 over 7 from both sides. That's equal to b. Just going to move over here. Finding a common denominator here, we can use a common denominator of 14. And so if we do that, we get 35 over 14 minus 8 over 14, which gives us 27 over 14. And so we know that the equation of this perpendicular bisector is y equals 4 over 7x plus 27 over 14.